Have you ever stopped to think about how different computer programs, maybe even on totally separate computers, actually find each other to get work done together? Today, we're going to dive into a really elegant, simple system that makes it all happen, and it does it without some central boss calling all the shots. Let's get into it.
So yeah, that's the big question, right? How do these independent programs team up without a central server micromanaging every single move? It's a super interesting problem, and we're about to break down exactly how this clever little system solves it.
All right, here's our roadmap. First, we'll meet our peers. Then, we'll see how the network actually gets built. After that, we'll look at how they find a partner, put them to work, and get the results back. And finally, we'll wrap it all up with the big takeaway.
First up, a system of peers. Before we can see how these programs work together, we really need to get to know the cast of characters. We got to understand who's who in this digital workshop.
So what we're talking about here is a peer-to-peer system, or P2P for short. And you should think of it less like a rigid corporate ladder and more like a workshop full of independent specialists. Each one of these peers is its own program, and they can find and talk directly to each other to get a job done.
And for today's explainer, here are our specialists. First, we've got the directory server. Think of it like a digital phone book. Its only job is to know who's available and what they're good at. Then we have our actual workers, our nodes. Node A is the addition expert. Node B is a whiz at multiplication. And Node C is our go-to guru for division.
Okay, so we've met the team. Now, let's see how this whole network actually springs to life. This is all about waking the system up and getting everyone online and ready to roll. Waking up this network basically happens in 4 pretty straightforward steps. First, we set up a clean workspace, and really, this is just a bunch of empty folders. Second, we start up the directory server. The phone book is now open for business. Third, each of our specialist workers, Node A, B, and C, they all check in with the directory, letting it know they're here and what they can do. And finally, the nodes go into serving mode, which is kind of like them flipping over the open for business sign on their digital door.
And this super simple folder structure is actually the secret sauce. By creating those folders, we've given every single worker its own personal inbox for getting new jobs and an outbox for sending the results back. It's basically a simple, file-based mail system. Pretty clever, right?
Okay, so the network is live, our specialists are at their desks, ready to work. But what happens when one of them gets a job that it doesn't have the skills for? Well, this brings us to the really crucial part, finding a partner.
Let's play out a little scenario here. Our addition specialist, Node A, gets a task to multiply 12 by 7. Now, it can add numbers all day long, but multiplication? Nope, that's not in its job description. So, what does it do?
It asks the phone book. It's that simple. Node A uses the lookup command you see here, which is just its way of asking the directory server, hey, I'm Node A, and I need to find somebody who can do multiplication, or MUL for short.
And this is the most important part to understand. The directory server does not do the math itself. Its only job is to find who can. It checks its records, sees that Node B is the multiplication expert, and it gives Node A this response, which is literally the exact file path to Node B's personal inbox.
So now, Node A has the contact info it needs. It doesn't have to talk to the directory anymore. It's time for some direct peer-to-peer action.
So, using that address it just got, Node A packages up the job. And look at the command. It's using that exact inbox path to send the task, multiply 12 by 7, directly to Node B. That right there is the peer-to-peer communication we've been talking about. No middleman.
And this quote from the source material just sums it all up perfectly. The directory is just an index, a phone book. The real work, all the communication and getting stuff done, happens directly between the peers, just by dropping files into each other's mailboxes.
So let's just quickly recap that flow, make sure it's crystal clear. Step 1, Node A does a lookup with the directory. Step 2, the directory responds with Node B's address. And Step 3, Node A uses that address to send the job straight to its peer. It's simple, it's efficient, and the directory isn't involved in the actual work at all.
All right, the job has been sent off. So how does Node A get the answer back? And what happens if a task is, impossible? Let's take a look at the results. Here we're looking at 2 examples that were sent to our division expert, Node C. On the left, a perfectly normal request, 100 divided by 5. The job gets done, and the status comes back, OK. But on the right, something trickier, 10 divided by 0.
The system is smart enough to know that's a no-go, and instead of just crashing, it properly returns the status equals error. That's really important.
And where do these results actually end up? Well, they land right back in the outbox of the node that made the request in the first place. So node B or C does the math, and then it drops the answer file right into node A's outbox. The communication loop is officially complete.
So we've seen the whole process now, from start to finish. Let's zoom out and talk about the big takeaway. Why is a simple system like this actually such a powerful concept? Well, it really boils down to 4 key ideas. First, the directory is just a phone book. It's for finding programs, not doing the work. Second, once those peers are connected, they talk directly to each other. Third, that communication can be incredibly simple, like just dropping a file in a folder. And maybe most importantly, this whole setup creates a clean separation between the job of finding someone to do the work and the job of actually doing it.
And that kind of leads us to one last really big question to think about. This system is great, but it still relies on that one central phone book. What would happen if you took it away entirely? How would these programs find each other in a truly, fully decentralized world? Answering that question is one of the most exciting challenges in computer science today. Something to chew on. Thanks for diving into this with me.